The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at objective 5C.1. Before we do that, I have an announcement, and that is this. So quite a few of us talked with the designers of the Math 80 course, and the conclusion was that there was too much information in it. I'm sure you all would agree with that. Consequently, the last chapter that's on the schedule, which is, let's see here, objective 6 or outcome 6, we're not going to cover it. So what does that mean? That's right. Oh, yes. So there you go. Good news. Thursday will be our last chapter test. Okay. There are 5 days that were set aside to cover chapter 6 and 5 days set aside to review for the final. What we're actually going to do is we're going to have 10 days to review. And this is how I'm going to do this. After the test on Thursday, so Friday, I will go back and I will go over the first objective and the review assignment and just go back through slowly reviewing, answer anybody's questions about anything. If we need to go off on a tangent and talk more about the least common denominator or prime factoring or adding fractions, we'll do that. And we'll go through and we'll look at the reviews for 5 days, and then we'll come back and I'll probably just go through like the test that you took or any questions that you have there. Again, we'll go back to the first objective and go through objective 1, 2, 3, 4, 5. So that's what's coming. Those of you that watch these videos or participate will know about that. The rest of them, well, I guess they'll figure it out. I'll try and send out some messages. But anyway, that's what's going to be happening. So if you're one of those people that's working ahead, this is it. This is the last chapter we're going to cover. All right, so having said all of that, let's take a look at some problems having to do with scientific notation. Let's see here. All right. And what I'm going to do today, I'm not going to do the actual problems in the assignment, but I'm going to do one similar to it to get you used to the instructions, because the instructions change back and forth some things. And so we need to kind of focus on that. So here is a problem, I'm going to say like number 1, okay? Multiply, and let me get my glasses on here, multiply 4.2 times 10 to the 4th power times 6.783 times 10 to the 9th power. Already I'm making a mess. No surprise there. Okay. First of all, I'd like to review a property that's called the commutative property of multiplication. What that says is that if we're multiplying two numbers, let's say we're taking 2 times 3, we can reverse the order and multiply them as 3 times 2. In either case, we get 6. Let's say we have a group of numbers being multiplied, 2 times 3 times 5 times 7. I can rearrange those factors and write them as 2 times 5 times 3 times 7. As long as they're all factors being multiplied, I can rearrange the order of them for convenience. All right. Now, what does that have to do with this problem? Well, the first thing we're going to do is we're going to rearrange the factors. We're going to write it as 4.2 times 6.783 times 10 to the 4th times 10 to the 9th. Is everybody okay with what I just did there? I'll take that as a yes. Next, on my calculator, I'm going to take 4.2 times 6.783 3. And when I do that, I get the following: 28.4886 times, here we are multiplying two powers with the same base. So we would add the exponents, and this would be times 10 to the 13th power. All right. Any questions so far? Now, let's take a look at the instructions. It says, note, the number of significant digits in the answer should equal the least number of significant digits in the numbers being multiplied. We're going to go away from this problem for a minute. We'll come back to it. Let's say we're conducting a scientific experiment, and by some means we're measuring data, and we come up with the following: 3.2 times 10 to the 7th power as an answer to something. And another piece of data in this same experiment comes up to be 8.73 times 10 to the 4th power, okay? But in the process of this experiment, we have to multiply these two numbers together, okay? So using very much the same idea that we did a minute ago, I get 27.936 times 10 to the 11th power. Okay, now this first number has two significant digits. This second number has three significant digits. Good science says this: you can't get a final answer that is more accurate than your least accurate piece of data. Since this piece of data only has two significant digits, and this one has three, our answer, and this is not the final answer, but our answer can only have two significant digits. So 27. Okay, that's the first piece. The second piece, it says the answer expressed in scientific notation equals which number? Well, this number isn't in scientific notation, is it? So what we're going to do is this: we're going to take the 27 and write it in scientific notation. Okay, 2.7 times 10 to the 1. Then we're going to bring down this power of 10 that we already had, and then we're going to put them together. So our final answer is 2.7 times 10 to the 11th power. It's in scientific notation, and it has the same number of significant digits as the least accurate piece of information. Courtney, question?
Would it be 10 to the 12th?
Yes, it would. Thank you. Apparently, I'm the one that's waking up. Sorry to confuse you right off the bat. My problem is, and this is not an excuse, it's just the reality of things, I tend to be thinking one step ahead, which means I'm not where I'm supposed to be. That's not a good thing. So thank you for that. I knew there was a reason that I had you here. Okay, now let's go back to the original problem. So here I have two significant digits. Here I have four significant digits. So my answer should only have two significant digits. So 28 times 10 to the, I'm going to check my power of 10 now and make sure I've got it right this time, 13th power. However, this is not in scientific notation. So this becomes 2.8 times 10 to the 1 power. And then we bring this down times 10 to the 13th power. And I get 2.8 times 10 to the 14th power. That's my final answer in scientific notation with the correct number of significant digits. Later on in your school career, if you take a chemistry class, there will be a lot of focus on significant digits involving chemistry. That's one of the places that it shows up the most. Anyway, do you have any questions about this particular example? Now, going back to question 1 over here, which is what I'm kind of modeling, There's a part B. It says the answer expressed in decimal notation equals which number below. Do you have a question, Mike?
Yeah, so when we're trying to stay to the significant digits, do we round?
Ah, that's a good answer. Yes, we do. Yes, we do.
Okay.
And that didn't really come out in this example because the 4 would have rounded down anyway. Let's see what the, you know what? I'm glad you asked that. So look what I did here. I messed up here too, didn't I? Boy. There. Good job. Thank you. Well, that's 2 mistakes. If I make 3 mistakes today, can I just go to jail, do not pass go and go back to bed? No? Oh, well. All right. So the next thing that we're going to do is we're going to take this number and we're going to write it as a decimal number without the powers of 10. So times 10 to the 14th power. Wow. That means I need to move the decimal point 14 places to the right. So I'm going to add a bunch of zeros. 3, let's see, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I actually added 13 zeros because this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's see. So I'm going to get that comma there and there and there and there. So 280. I'm not sure what that is yet. So 1, 2, 3, 4. So this is what? 1,000, million, trillion, 280 trillion. That was my salary last year. Ha! Just kidding. It's more likely the national debt or something. But anyway, so here is the answer in scientific notation with the correct number of significant digits. Here's the answer written as a decimal number. All right. Any questions about that example? So again, we've got a lot of things to consider there. This whole idea of scientific notation, significant digits, etc. All right, let's take a look at problem number 2. So this is going to be like number 2. Multiply the following and express your answer in appropriate scientific notation. And then it says to enter numbers in scientific notation. Here are some instructions that you'll need to follow to get this entered correctly. I'm going to go ahead and do the actual problem so that we can see how it works. So I've got 3.5 times 10 to the 47th power times 7.2 times 10 to the 14th power. All right. So the next step I would do is I would put the decimals numbers together and the powers of 10 together. Notice in my example before, I didn't put an X here. Do I need it? Technically, no, because parentheses next to each other means multiplication. Okay, so I didn't put it here, but I put it here because I'm just copying what they did over here. All right. So 3.5 times 7.2 is 25.2 times 10 to the 47 plus 14th power is 61st power. All right. Now, this is not scientific notation because there are 2 digits to the left of the decimal point, and there needs to be just 1 non-zero digit to the left. So again, I'm going to take this and write it in scientific notation, and then bring this down, and then put these together. Now, you might say, well, wait a minute, you have too many digits. Okay, in this problem, it didn't ask about least significant number of digits, okay? So you got to read the directions for each problem. Don't just read one set of directions and then do them all that way. It changes. Okay. So in this problem, we're going to have this. All right. It says to enter numbers in scientific notation, use the X for the time symbol and use the exponent symbol above the 6. It's called a little caret key. For example, okay, so here's the answer. All right. And to put it in here, I'm going to put in 2.52. Then I'm going to use a lowercase x, no space, just a lowercase x, and then a 10. And then I'm going to use that little caret key that's above the 6 on your keyboard. So shift, there's the little caret. Okay. And then a left-hand parentheses, which is above the 9, and a 62, and then a right-hand parentheses, which is above the 0. Okay with that? And we'll submit that question and see that it's correct. We okay with that? Any questions about how I did that? So just make sure that you follow the directions on how to type things in. So it'd be a shame to get the right answer and put it in incorrectly. All right. We okay with that? All righty. Let's go on and take a look at question number 3. And we're going to do one that's like number 3. It says divide. And we're going to take, let's see here, 2.47 times 10 to the 5th power divided by 3.8 times 10 to the negative 5 power. Note, the number of significant digits in the answer should equal the least number of significant digits in the numbers being divided. So here again, we're going to take into play the significant digits. All right. What I'm going to do here is I'm going to split this problem apart. Like this. Now, if anybody has any questions about how can I do that, why is that legal, whatever, speak now and I will explain. Otherwise, I will continue. So anyone have any questions about the legality of what I just did there? All right. So next, we're going to take the 2.47 divided by 3.8. And I get 0.65. And then times dividing 2 powers with the same base, we're going to get the base with the top exponent minus the bottom exponent. So we're going to subtract a negative. Okay, it's the 5 minus the negative 5, which becomes 0.65 times 10 to the 5 plus 5, because subtracting a negative is like adding a positive. Okay. We're not done yet, but so far so good. Now, I have the right number of significant digits, that is the 6 and the 5. The 0 on the left does not count as a significant digit. But the problem is it's not in scientific notation yet, is it? So what we're going to do is take this part of the problem and write it in scientific notation. That's going to be 6.5 times 10 to the negative 1 power, because we're taking this number and making it larger. So we have to multiply by a negative power to bring it back down to where it's equal to what it was to start with. Remember that from yesterday? And then times 10 to the 10th, that comes down. Then I'm going to put my 2 powers of 10 together. 6.5 times 10 to the negative 1 plus 10 is 9. Now, significant digits. I had 3 of them here and 2 of them there. So I want 2 of them. I have that. I have 1 non-zero number to the left of the decimal point. So this is the correct answer in scientific notation and with the correct number of significant digits. Any questions about that? All right, and then part B, the answer expressed in decimal notation equals what number? So let's find out. Let's see here, 6.5 times 10 to the 9th power. So we're going to move it over 9 places. So there's 3, 4, 5, 6, 7, 8, 9. Notice I'm not adding 9 zeros because I'm going to use up 1 move right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, comma, comma. So 6, 5, 0, 0, comma, 5, 0, or 0, 0, 0, 0, 0, 0. And that is what trillion, 6,500,000,000,000. Any questions about that? Okay, let's see here. Problem number 4 is very much like the one we just did, so I'm not going to do another one that it's same idea. You're going to divide, you're going to use significant digits. In this case, you're going to have what? 4 significant digits. So I already can tell that the second answer and the fourth answer have too many digits, don't they? Yeah. And then we'll change it into a decimal number. Let's see here. This, they just want the result as a decimal. So we've got 2 numbers in scientific notation. We're just going to multiply them together to get a decimal answer. We'll do something, we'll say like number 5. So let's see here. How about let's find one here. 7.23 times 10 to the 4th times 8.16 times 10 to the 13th. Okay. So again, this is like number 5. Evaluate and express the result as a decimal. So here, we're not concerned about scientific notation. However, in my calculator, I'm still going to put these 2 numbers together and then multiply them by this. Let's see here. 7.23 times 8.16, and I get 58.9968. Okay, and that's going to be times 10 to the 17th power. Now, this answer is not in scientific notation, but it's also not a final, just pure decimal answer. Okay, but the question we're doing one like number 5 doesn't ask for scientific notation. So basically what I'm going to do, I'm going to move the decimal point 17 places to the right. Oh boy. Well, we've already got what, 4 of them to get to the 8. So 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Why did I pick such large numbers? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's see, there'd be a comma there, 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 and there. So 8 something, or 5 something, 899, comma 680, comma, and then what? 4 sets of zeros. Oh, what do we got here? We've got billion, trillion, because I don't even know what that is. It's a big number, but I don't even know what the name of it is. Oh, well. All right. Any questions about that example? Okay. Evaluate. Let's take a look at one like number 6. Just for a minute, let's look at the actual problem number 6. Express the result in scientific notation. Can you already see that the first two answers could not be correct because they're not in scientific notation? Okay. Tell you what, let's do this problem. So we'll actually do number 6, 5 times 10 to the negative 12. 6 times 10 to the 6th power is going to be 5 times 6 times 10 to the negative 12 times 10 to the 6th, which is 30 times 10 to the negative 6. Okay. So this is going to be 3.0 times 10 to the negative 1, and that's times 10 to the negative 6. So 3.0 times 10 to the negative 7. Oh. I've messed up somewhere. Don't help me. Don't help me. I know where I messed up. Right here. What should that be? Anybody?
+1.
Good job. Boy, it's a good thing I had multiple choice answers to choose from, huh? So I think it's going to be that one. Let's see if it is. Yep, there it is. Okay. All right. We've done one like that. We've done one like that. Done one like that. Here we go back to significant digits again. Okay. Tell us how to type it. So, all right, so I've done at least one example of all the different kinds. Do you want any more examples of any types of the problems there? We've got multiplying and dividing. We've got scientific notation, significant digits, decimal notation. Anything you want, any more examples of there? All right, again, I caution you, read the directions for each problem, because look here, let me just show you. Here it says significant digits. Here it doesn't. Here it says significant digits. Here it doesn't. Here it doesn't. Here it doesn't. And then all of a sudden, oh, here it is again. So don't skim the instructions, read them. All righty. Well, I'm going to go ahead and stop the recording.